Hello everyone. Let us continue learning C++ programming. In our previous video, we discussed about classes and objects, and also we discussed about some of the access specifiers in C++ programming, and those are public, private, and protected. And we also looked into the characteristics changes of each of the access specifier. And in this video, we are going to discuss about yet another important topic in OOPS concepts, that is inheritance. To be more specific, inheritance is one of the key features of OOPS languages, which allows you to inherit the properties and the functions of one class into another class. Let's get started. Inheritance in C++. The inheritance is all about the capability of a class to derive the properties and the functionalities from another class. And this is defined by the word called inheritance. The two common terminologies in inheritance are subclasses and superclasses. Subclass is a class that inherits the property from another class. Likewise, it is also called as derived classes. Superclass are the classes whose properties are inherited by the derived class or subclass. Now let us all begin with why to use inheritance. For example, consider you are creating a project in which a class is being used that represents the group of vehicles, and then further you are in need to create independent classes for each of the type of vehicles like buses, cars, and trucks. Now there could be some common functionalities like filling up fuel, the capacity, apply brakes, or some of the features which is said to be common across all the vehicles. In this scenario, if we could create a parent class which is considered to be a vehicle class and which possesses the basic functionalities that is needed by any vehicle, and furthermore to add up in our subclasses like car, buses, or trucks, if there is any specific functionality that we need to add, it could be incorporated, and the core functionality of vehicles can be inherited from the base class. So this solves the problem for us. And moreover, the hierarchy of having one base class as vehicles and having multiple derived classes like cars, buses, and trucks independently helps us connect with a lot of real-time entities and values, which in turn makes it much easier for the reader to read and understand the code what you have written. Inheritance also plays a major role in avoiding the chances of data redundancy and data duplication. Inheritance also comes with three modes of inheritance, which is very similar to your access specifiers. It could be either a public inheritance or a private inheritance, or it could be a protected inheritance. Let's see how. Let's get started with a quick program. And I'm saving this file as program3.cpp, where CPP is an extension for your C programming files. And the first line of your code will be your header file section, where I'm including IO stream, which is the necessary header file for C++ programming. And in the very next line, I'm including my namespaces. Namespace std, which is a standard namespace that we need to use for using the cin and cout statements. Now I'm beginning with the declaration of a base class. Hence, I'm calling my class name as base. And any declaration in C++ programming should end with a semicolon. So there is a semicolon in place, inside which I'm creating some of the public members into data. So data is an integer type variable, which is a public member of the base class. And also I'm creating a constructor which sets my data to a value of 45. Now, if we need to derive the base class into a derived class, I'm creating yet another class with the name of derived. So this represents my derived class, and this symbol of colon represents your inheritance, and this is the place where I have to specify the mode in which I'm going to derive. And here I have to provide my base class name. This is your common syntax of inheritance in C++ programming. So the mode is nothing but I can give either public, private, or protected. Public, base, and here I'm just going to have a derived constructor alone, which sets my data to a value of 41, and creating a main function. Declaration should end with a semicolon, and inside the main function, I'm creating an object for derived class. I'm printing the data inside it. and I'm ending with the return 0 statement. This is all about a common inheritance part. Let's compile this code with our G++ compiler. G++ space, the file name, which is program. Oh, sorry, the folder has to be switched. CD/CD cpp. G++ program 3.cpp -o, and we are supposed to provide an object file name. And the object file name, I prefer it as pro3. And the compilation is in progress. Now here is an error message we see on the screen, which says derived, which is a constructor function inside a derived class, is private within this context. So what does this error means? Okay. Now here in the derived class, as you could very well see, we have not provided any of the access specifiers in place. We have not mentioned as public or private or protected. So if no access specifier is mentioned, what is the default access specifier that is used by the compiler? The default access specifier that will be used by the compiler is always private in C++ programming. So remember, this is a very common question that could be asked in your HR interviews or the MCQs part in your placement drive or the company selection process. So the default access specifier for any class objects is private. Since it is not mentioned, I prefer mentioning it as public. Now let's compile it yet another time. Now you could very well see there are no errors. So I'm clearing my screen and I'm going to run the program, which is pro3.exe. And when I run this, you could see the data that is printed as 41 because it is constructed with the help of the derived class constructor, and the object is basically a derived class object. If instead of being a derived class object, if I call this as a base class object, we'll compile it. I'll run this file. It prints the data of 45, which is set by the base class constructor function. Hope this idea is clear about how your inheritance works. And there are several modes of inheritance: public inheritance, private inheritance, and protected inheritance. Let us see what are the changes it could cause in terms of inheritance played against your modes of access specifiers. Let's see. Okay, assuming, let us talk about modes of inheritance against access specifiers in base class objects. So the modes of inheritance can either be public or private or protected, and the access specifiers can either be public, private, or protected. Now let us see what happens. If the inheritance is considered to be a public inheritance, that is, mode of inheritance is considered to be public. Now first thing first, private members of any class is not accessible outside the class. So it could be whatever the way you inherited, private members are not accessible. So all these private members, I'll mark this as NA, meaning that it is not accessible. Despite being your type of inheritance, the private members are not accessible. If there is a data member inside your base class, which is defined as a public member, in public inheritance, public mode of inheritance, it remains public. If it is a private inheritance, it becomes private. If it is a protected inheritance, it becomes protected. Now, what happens with your protected members? If the data member is already a protected member in your base class, and if the mode of inheritance is public, the member still remains protected. If it is private inheritance, the protected member becomes private member. If it is a protected inheritance, it remains protected. And this is in common about the data members against your modes of inheritance. This is a quick little detail which you can remember. The modes of inheritance against the access specifiers of the base class objects. And that's all about the modes of inheritance. Now let's quickly have a look at the types of inheritance. In any OOPS language, there are several types of inheritance that can be performed, and let's see what are those. The first type is a very common type of inheritance in any OOPS language, which is single inheritance. There is only one base class and one derived class, and that derived class inherits properties only from the base class. So it is basically an one-to-one connection. The second type of inheritance is called multiple inheritance, where one derived class inherits properties from two or more base classes, and that is called as multiple inheritance. This is basically a kind of many to one association. And the third one is called multi-level inheritance, which is basically kind of an ordered sequence. Like you have your grandfather, where your father inherits properties from your grandfather and you inherit properties from your father. So the order is grandfather, father, and you. And these kind of levels of inheritance is called as multi-level inheritance. Now the fourth type is called hierarchical inheritance. Now the ideology of hierarchical inheritance has a lot of inferences with multi-level inheritance. Now, the common differences between multi-level and hierarchical is nothing but your father is the only son of your grandfather and you are the only son of your father. In that case, from grandfather, the only person to inherit from your grandfather is your father, and the only person to inherit from your father is you. And this is called as multi-level inheritance. If there is a case of your father has a brother or a sister and you have a brother or a sister, in that case, from your grandfather, both your father as well as your uncle or aunt also inherits from your grandfather, and from your father it will be you along with your brothers and sisters who will inherit from your father. And this kind of a structure is called as hierarchical inheritance. And the next type of inheritance is called as hybrid inheritance. This is basically called as a virtual inheritance, where you implement multiple types of existing inheritances in place to create a new inheritance structure, which is absolutely user defined. You can combine hierarchical with multi-level, multi-level with multiple, multiple with single. You can do it in n number of ways and create a unique inheritance model depending upon your project. And those kind of inheritance is called as hybrid inheritance. So let us summarize the types of inheritances. The first one we discussed about is single level inheritance, which is basically one-to-one association. And then we had multiple inheritance, which is basically many-to-one association. And next we had multi-level inheritance, which is kind of your family structure with only one person, with only one child at each level. And then we had our hierarchical inheritance, which is basically having minimum of two childs at each level, which is minimum of having two children at each level. And finally, we had something as hybrid inheritance, which is basically a virtual mode of inheritance in which we implement concepts of both hierarchical, multi-level, and multiple combined together as a sandwich model to create a new form of inheritance, which is absolutely user defined. And that's it all about inheritance. And yet again, we come up with a question of, will there be any way to access the private members of a class, of the base class, in my derived class, or anywhere else outside the base class? So what could be the possible solution we can provide? And that is being done with a special keyword in C++ programming. Let us see what it is in our next video. Stay tuned. See you in the next part of the video. Thank you.